Hello, and welcome to our last video on graphing trigonometric functions. Today we're going to look at tangent and cotangent. And I'm going to start with cotangent, then move to tangent. Okay, so our formulas are going to look very similar. We're going to have y equals a times either tangent or cotangent, b times x plus h plus d. Going to look very similar to the formulas we've been doing, but a few things are going to change. A is still going to be the stretch up and down. So in other words, the vertical stretch. If A is a big number, our graph is stretched tall. If A is a small number, our graph is squished down. If A is a negative number, our graph is flipped upside down. Our period is going to be very different, however. Our period, both for tangent and cotangent, instead of being 2 pi, our base period is only 1 pi, so the formula becomes pi divided by b. So tangent and cotangent, their period is half as long in order to complete a cycle. Now the other parts are the same. So the vertical shift is still d, and the phase shift is still the opposite of h. Those have not changed. But let's take a look at the pictures. Now, cotangent is the one most similar to what you're used to. So I'm going to do cotangent first. We're going to do 2 examples of that, then we're going to do 2 examples of tangent. So let's start with cotangent. Well, just like before, I'm going to start by drawing a box. But here's what's going to be different. I've got my horizontal line. My horizontal line is going to be my vertical shift, just like normal. But here's the big difference. The left edge of tangent doesn't have a top. The right edge of tangent and cotangent doesn't have a top. See, tangent and cotangent, they keep going up or down forever. They don't have a top or bottom to the box. Now the number line here in the middle, I'm going to split it into 4 equal pieces, just like we were doing on graph paper. So I've got wherever I start, then 1, 2, 3, 4 pieces. And this horizontal line, again, is still going to be the vertical shift. But the rest is going to get kind of complicated. If I'm drawing cotangent, then just like we're used to, this left edge of the box is going to be the phase shift. So this left edge of the box right here is going to be x is equal to the opposite of h. In other words, x is the phase shift. And just like we're used to, this edge of the box is going to be the phase shift plus the period. So this edge of the box right here is going to be x equals the phase shift plus the period. Now what about what's going on in the middle? Well, here's where things get very different. When we graph cotangent, cotangent is going to cross only here on the horizontal axis. And it's going to head to the left, upward, toward that asymptote. As we go to the right, cotangent is going to head downward toward this asymptote. But it's not going to have a top, not going to have a bottom. It's going to keep going forever. So let's try a specific formula, see what that looks like. So as an example, suppose I had y equals cotangent of 1/3 x. Just as a quick example. All right, then you'll notice right here, if I match up the parts, my A is 1, so I have a vertical stretch of 1. In other words, it has not been stretched or squished at all. If we look at B, my B here is 1/3. My period is pi divided by b. So my period is pi divided by b, which is 1/3. And pi divided by 1/3 is 3 pi. My vertical shift would be d. Well, I don't see anything added here, so we have no vertical shift. And phase shift would be h. Well, Again, that would be something added or subtracted to x. We don't have anything like that, so we have no phase shift. And now I'm ready to draw my picture. So I want to draw this particular picture, cotangent of 1/3 x, and here we go. The left edge for cotangent is just like we're used to with the box before. The left edge is the phase shift. So in this picture, the left edge is x equals 0 because there is no phase shift. The right edge is the period plus the phase shift. So here, my period is 3 pi, added to my phase shift of 0 means that this edge right here is 3 pi. Now, you notice I haven't talked about stretch yet. I'm going to talk about stretch in just a minute, but let's get a couple of other things taken care of. Since this is x equals 0, I can also say that this is the y-axis. What if I want to find all of these spots in between? Well, then I'm going to use the same trick I used from the last video. I'm going to start by finding this number in the middle. You find the middle number by adding the two numbers on the end and dividing by 2. So 0 plus 3 is 3. Divided by 2 tells me that this spot right here is 3 pi over 2. Now suppose I want to find this one. Well, then I'm going to add these two together. So that's x equals 0. Plus 3 pi over 2, 0 plus 3 over 2 is 3 over 2. Divided by 2 is 3 over 4, so this is 3 pi over 4. Now how about this one right here? I'll pick that up in a minute. Now how about this one right here? I've got 3 over 2 plus 3. That gives me 9 over 2. That's 3 over 2 plus 6 over 2 is 9 over 2. Divided by 2 tells me that this spot right here is 9 pi over 4. So that takes care of all the lefty-righty of the picture. Now what I want to do is the uppy-downy. Well, horizontal axis right here is the vertical shift, and in this particular case we have no vertical shift, so y equals 0 is this line. My vertical stretch is 1, so I'm going to go up 1 unit here and mark that, and I'm going to go down 1 unit and mark that. But what I'm going to use that for is going to be a little bit different than before. Here's what I'm going to do instead. Now remember, I'm drawing cotangent, and cotangent tends to come down like this. It has to pass through that point right in the middle, and then it's going to come down even more. And sometimes what I need is I need a little help knowing how high or low to draw it. So that's where this height is going to come in. If I look at this height right here, and I mark it with this position left-right here, I find at that point right there, that's at x is 3 pi over 4 and y is at a height of 1. And my graph must pass through that point on its way to passing the horizontal axis at 3 pi over 2. Now similarly, over here at 9 pi over 4, I want to find the spot that's even with -1. So that's right about there. And so now as my graph keeps going down, I'm going to pass through that point and keep on going down. And there is a graph of one period of cotangent 1/3 x. Let's do another example of cotangent, then we'll move on to try tangent. So here comes a long one. Y equals -2 cotangent x minus pi over 3. Let's turn that down. -2 cotangent x minus pi over 3 minus 5. Okay, so going through the parts, I have a -2 is my a, so my stretch is the absolute value, which is 2. My period is 1 pi divided by b. 1 pi divided by b. Now I don't see a number here, so I know b is 1. So I have 1 pi divided by 1 equals pi. My vertical shift, of course, is this number right here being added or subtracted. So my vertical shift is -5. And my phase shift is the opposite of h. So my phase shift is positive pi over 3. So now I want to try and draw that graph over here. I'm drawing cotangent, so I draw my horizontal axis, and I have a vertical asymptote at the left and a vertical asymptote on the right, and I'm going to divide this up into 4 equal pieces. The left edge is the phase shift, so I take a look. My phase shift is pi over 3, so the left edge is x equals pi over 3. Notice that's not the y-axis. The y-axis is x equals 0. So the y-axis must be somewhere over here on the left somewhere. We're not going to worry about it too much, but it's somewhere over there. What about over here on this side? Well, on this side, I need x equals the phase shift plus the period. Well, my phase shift is pi over 3, and my period is 1 pi. 1 plus 1/3 is 1 1/3, or in other words, 4/3. So I have 4 pi over 3. So there are my 2 pieces. Now, remember, cotangent normally is going to start up high, and it's going to come down through the middle. It's going to cross at that middle spot and then head downward. Now, in this case, I have a -a. So instead of starting at the top and going downward, I'm going to flip upside down. I'm going to start at the bottom and go upward. But no matter what, I still need to cross here at the center. So I want to find out where is that center. Well, again, just like before, I'm going to do that by finding halfway between the 2 ends. 1/3 plus 4/3 is 5/3. Half of 5/3 is 5 over 6. So this right here is 5 pi over 6. What about these other spots? Well, right here, that's pi over 3 right there. That's 1/3 plus 5 over 6. Well, let's see, 1/3 plus 5 over 6. 1/3 is 2 over 6. So 2 over 6 plus 5 over 6 gives me 7 over 6. Divide by 2 gives me 7 over 12. So this spot right here is 7 pi over 12. How about this one right here? Well, that's 5 over 6, and this is 4 over 3. 4 over 3, that's the same as 8 over 6. So I have 5 over 6 plus 8 over 6 gives me 13 over 6. Divide by 2 gives me that this is 13 pi over 12. And that takes care of my lefty-righty. So now let's think about uppy-downy. Right? My vertical shift is -5. So this line right here must be y equals -5. Not the x-axis. The x-axis is up here somewhere. Y equals -5. My stretch is 2. So if I go up 2 units, right about there, that would be y equals -3. And if I go down 2 units, that would be y equals -7. So now I'm ready to draw my cotangent. Remember, normally cotangent starts high, goes down through the middle, and then keeps going down. But this is a negative cotangent, so I'm going to start at the bottom. I'm going to come up in an S shape, go through the middle, and on up. Where am I going to cross? Well, let's see. Over on this side, I'm coming up, I'm coming up, I'm coming up. I need to go where -7 is and 7 pi over 12 is, which is right about there. So my graph is going to pass right like that. And then what about over here? Well, now I'm going to do y equals -3, crossed with 13 pi over 12 for the x, gives me right about there, and there is my graph. I have an asymptote at pi over 3, I have an asymptote at 4 pi over 3, and I have the graph rising here in the middle. Again, it's rising instead of descending like the first picture because of the negative. So that's cotangent. Cotangent's not too different from the ones we've been doing last time. The phase shift is still on the left. The right side is still phase shift plus period. We're still dividing the number line into 4 pieces. The big difference is our period is only pi divided by b instead of 2 pi divided by b. So how about tangent? We talked about cotangent. Let's take a look at tangent. Now, tangent is particularly tricky. So we got to be really careful when we get into tangent. Now, I'm going to show you how it's tricky. And once you see it, you'll know what to keep an eye out for. Basic picture is going to be the same. I'm going to have my horizontal axis. I'm going to have an asymptote on the left. I'm going to have an asymptote on the right. I'm going to have 4 equal pieces in between. Tangent normally looks like negative cotangent. It starts at the bottom, makes an S curve up through the middle, and then on up to the top. So something like this. Negative tangent would flip upside down. Negative tangent would look a lot like regular cotangent. But here's the big difference. The phase shift is not on the left. The phase shift is in the middle. Make a careful note of that. That tricks people all the time. The phase shift on tangent is in the middle. So let's take a look at an example. Let's start with a simple one. Y equals just plain old tangent of x. I'm not even going to do anything fancy with it. So plain old tangent of x. If we go through the parts, we see that there's a 1 right there for A, so the stretch is A. We see that there's a 1 right there for B, so the period is pi divided by B, or pi divided by 1, so the period is y, pi. We have no vertical shift and no phase shift because we have no numbers being added, subtracted over here. And so that means that this spot on my number line, which is my phase shift, this spot on my number line is 0. Well, if that's 0, how am I going to find this spot and this spot? Well, the thing you got to remember is that period means the length of the entire cycle. So from over here at this asymptote on the left, all the way over here to this asymptote on the right, that's what the period is. And notice that where my phase shift is cuts the period in half. So if I want to find where this line goes, I've got to take the phase shift and then go to the right half of the period. And going to the right, of course, means addition. So starting with 0 as my starting point, I'm going to go to the right half of the period. The period in this case is pi. So half of that is pi over 2. So 0, going to the right, plus 1/2 of pi tells me that this line right here is x equals 1/2 of pi, or pi over 2. What about going the other direction? Well, again, 0 right here, the phase shift, is the middle of the period. So I'm going to go to the left now, half of a period. Well, if the middle is 0, and I'm going half of pi, to the left means subtraction, so 0, take away half of pi, tells me that this spot is x equals negative 1/2 of pi, or negative pi over 2. What about vertical stretch? Well, vertical stretch is going to work just like it did for cotangent. I'm going to draw a vertical axis, and in this case, since this is x equals 0, I might as well draw it in because it's the y-axis. So there's my y-axis. Here is my horizontal axis. I have no vertical shift, so my horizontal axis is the line y equals 0, which is the x-axis. I have a stretch of 1, so I'm going to go up 1 unit and down 1 unit. And I'm going to use the same trick I did before. Tangent is going to start down low, it's going to rise, it's going to cross the middle, and then keep rising. I'm going to use this mark right here and that mark right there to tell me that tangent has to go through that point. And I'm going to use this mark right here along with this mark right here to tell me the tangent has to go through that point. So starting at negative infinity, tangent rises until it hits the center. It must always cross the center, just like cotangent, and then keeps rising up like that. And so there is a picture of regular old, plain old tangent. What about these spots on the edges here? Well, those are easy enough to find, again, using our trick before. This spot right here is halfway in between 0 and pi over 2. So 0 plus pi over 2 is pi over 2. Divided by 2 tells me that this spot right here is pi over 4. And over here, I'm halfway between 0 and negative pi over 2. 0 plus negative pi over 2 is negative pi over 2. Divide by 2 gives me negative pi over 4. And so there's a graph of standard regular basic tangent. Again, the tricky part, the phase shift is not on the left, it's in the center. Every other graph we ever drew, we put the phase shift on the left. For tangent and tangent only, the phase shift goes in the middle. Let's do one more. So here comes our last example. Y equals 4 times the tangent of 1/2 x plus pi over 2. So first I'm going to draw my box. My box looks different, but I'm still starting by drawing my box. Here is my horizontal axis. I have an asymptote on the left. I have an asymptote on the right. And my picture is divided into 4 equal pieces in between. I'm drawing tangent. My stretch is 4. So I'll go ahead and put down absolute value of A, absolute value of 4. My stretch is 4. My period is pi divided by B. B in this case is 1/2. So my period is pi divided by 1/2, which gives me 2 pi. Vertical shift, I have nothing at the end, so there is no vertical shift. Phase shift, I do have an H, which is pi over 2. Phase shift is the opposite, so my phase shift is negative pi over 2. So now I'm coming over here, I want to draw my picture. Let's start with lefty-righty again. My phase shift is negative pi over 2. This is tangent, so phase shift goes in the middle. So right here, that spot is negative pi over 2 right there. My period is from one end all the way to the other. My period in this case is 2 pi. But remember, my phase shift is in the middle. So if I want to find the spots at either end, I got to take my phase shift plus half my period. Well, 2 pi is my period, so half of that is 1 pi. I'm going to take 1 pi going to the right, so I'm adding negative pi over 2, add 1 pi, that's negative 1/2 plus 1, and 1 is the same as 2 over 2. So negative 1 over 2 plus 2 over 2 gives me positive 1 over 2. So this line is x equals positive pi over 2. What about this line right here? Well, again, I'm starting from the phase shift, which is negative pi over 2, and I'm going to the left by half of the period. The period is 2 pi, so half of that is 1 pi. I'm going to the left, so I am subtracting. So I have negative 1/2 minus minus 1. So in other words, negative 1/2 plus negative 1 gives me negative 1 1/2, or negative 3/2. So this is x equals negative 3 pi over 2. So there are my asymptotes. I have one at x equals negative 3 pi over 2. I have one at x equals positive pi over 2. Let's go ahead and find the middle numbers. Well, this one's pretty nice. Negative 1/2 plus 1/2 equals 0 divided by 2. This spot must be 0, which means, by the way, this is also the y-axis, because the y-axis is wherever 0 is. What about this one over here? Well, again, we add and then divide by 2. Negative 3/2 plus negative 1/2 is negative 4/2. Divide by 2 is negative 4/4, or in other words, negative 1. So this right here is negative 1 pi. So we have negative 3/2, negative 2/2, negative 1/2, 0/2, 1/2. That takes care of my left, right. Now what about the uppy, downy? Well, again, I have a stretch of 4. So from the vertical axis, I'm going to be going up by 4 and down by 4. But I can't just put positive 4, negative 4 here until I check the vertical shift. I have a vertical shift of 0. So this is the line y equals 0, or in other words, the x-axis. And so now 0 up 4 units means this is a height of 4. 0 down 4 units means this is a height of negative 4. And I can use these spots to help me draw my picture. I'm drawing tangent. Remember, tangent starts down low, rises up, and then keeps rising. So if I want to find where tangent is going to go, it's got to pass through the middle, and it's got to pass through where this crosses with that. So that's going to be right about there. Again, I know it's rising, rising, rising. That's how I know whether to look up or down. And then over on this side, I'm going to have to cross right there. And so my graph of tangent looks like that. So here's our last two trig functions, tangent and cotangent. Notice cotangent is pretty similar to the ones you've been doing. The only big difference is the period is pi over b instead of 2 pi over b. Notice tangent, however, tangent's kind of squirrely. It's a little weird because the phase shift all of a sudden is in the middle instead of being on the left where it always was before. So that's something you're going to have to watch pretty carefully as you try some.